97.5% of everything that can be seen is inaccessible to our eyes. Among the vast variety of forms of radiation found in the universe, which we group under the term electromagnetic spectrum, only a very small part is accessible to our senses. This is the visible range. It's as if, on the stage where nature puts on its show, the curtains were barely cracked open. A few weeks ago, we became curious about what's behind this curtain, what we might see if we could detect more energetic types of light. If you haven't seen it, check out that episode. It covers types of light that pass through walls and reveal the inside of matter. Today, we'll imagine what we'd see if our eyes could perceive this side of the stage and explore lights with wavelengths longer than visible light. Let's start by playing the mad scientist and take an interest in infrared. And let's pause on this idea, which is very strange when you think about it. We are all sources of light. In the infrared range, we are all bright and luminous. We literally emit light. An idea that would appeal to some ancient Greeks who believed we emitted rays from our eyes that bounced off objects and returned to us. In the infrared range, we really do emit rays. And that concerns the whole body, the eyes as well as the backside.
As a result, if our vision had developed to perceive this light, we would be able to see every living being as a walking light bulb faintly illuminating its surroundings with a low energy light. And the colors as we know them would be replaced by shades associated with the heat emitted by objects. What's strange is that when observing the world in infrared, we realize that some materials are permeable to this light, while others block it. A window that lets visible light through, for example, turns out to be an impassable barrier for infrared. But for a trash bag, it's the opposite. Infrared light is your internal fire. It's a part of the energy from food that's released as heat. It's the fire that burns inside you and keeps you warm. If you could perceive the world in this spectrum, with experience, you'd probably be able to tell just by looking if your neighbor has a fever or is starting to get hypothermia, or clearly notice the signs of sexual arousal. You would literally see a wide range of temperatures and be able to judge how hot an object is just by looking at it. You could instantly tell if an engine was off for a while or if your house is well insulated. At some wavelengths, you could even see blood flow. We're tempted to imagine this vision as shades of red, orange, and yellow. But strictly speaking, that's not accurate, because colors are a reinterpretation of light by our brain. We'd have to imagine new shades and colors, which is flat out impossible. From space, Earth would look unrecognizable, because clouds and water vapor absorb these rays. You'd only see clouds moving, and no stars would be visible. It's not that they don't emit this light, but the atmosphere absorbs it before it reaches you. To see the sky, you'd need to go to space, where it would look like this.
Let's continue our dive into the invisible worlds to explore the realms of microwaves and radio waves. The part of the spectrum that is located here, what would we see if we detected this kind of light? That's what artist Nikolai Lamb wondered, who is trying to represent here the light known as Wi-Fi, which occupies the radio frequency band of the electromagnetic spectrum between radio waves and microwaves. We would be in big cities, bathed in spheres radiating from their source, with a signal fading with distance. If you could see all radio frequencies and microwaves, buried objects would no longer be hidden. You'd be like a metal detector. By taking a plane, you could help pilots see in the dark, and even in bad weather, by distinguishing the terrain through detecting reflected radio waves. Imagine every radio station, TV channel, and satellite broadcasting around you on various frequencies, with all that light constantly bathing everything around you. This would let us see everywhere, even at night. Radio antennas would look like constantly glowing giant light bulbs. Here is Architecture Radio, an application that gives you an idea of what a beautiful mess that would be. Depending on your location, the radio transmission towers, the position of communication satellites, and Wi-Fi routers, the app displays the radio signals that are probably all around us. A beautiful way to make the invisible visible, the hidden world of digital networks. Then, according to this article, where a researcher has fun calculating the size our eyes would need to be to detect wavelengths in the microwave range,
well, we would need pupils at least 5 meters wide, and the eyeball would have to be even bigger. All that just to be able to tell by sight if there's a good Wi-Fi connection. Otherwise, if you want to see microwaves without necessarily undergoing eye surgery, it's really simple. You just have to turn on your TV, or to be more precise, your old TV. Because with a cathode ray tube set, it's possible to observe what's called the cosmic microwave background, the moment when the universe turned on the lights, having expanded enough to let that light travel. This radiation comes to us from a time when the universe was only 1,000 years old, the age of an infant on a cosmic scale. This birth cry bathes the entire universe in a faint radio whisper, a tired light that radiates in microwaves and accounts for about 1% of the static that appears on our old screens.
And if now we suddenly opened up the whole scene to see the entire electromagnetic spectrum, everything that's hiding behind the curtains, what would we see? Well, assuming we could see all the ranges of light found in the universe at the same time, it's a safe bet that this world would overwhelm us, because we could never completely turn off the light. We'd be overwhelmed from all sides, possibly going blind or insane. There would be no darkness and almost no shadows left. In every direction, everywhere on the horizon, all objects and all matter would be translucent like glass. Opaque to some rays, transparent to others, but there would always be a light that manages to get through. And when you look at someone, you would see them somewhat like an anatomical Russian doll. All things considered, I'm quite glad to see nature only through the small keyhole. And if you think that's awesome, copy and paste it and send it to lots of friends. Thanks to all the supporters who gave from the heart.